Well, you might not have the coordination to juggle in real life, but with the discipline coordination schedules we provide on the MEP Productivity Pack, you can sure juggle and manage the data that's necessary for a building information model. Let's go take a look in Revit at some of those schedules and how they can work to your advantage. Now, I've already shown on the cover page in a couple of other demonstrations that we have here about how we've got these little design properties windows. Most of these are mechanical in nature right now, but you can see I've got some design air properties talking about the altitude I'm working with, the density of the air, some properties like that. Also, design gas properties. I showed this in the custom gas flows video, so take a look at that one if you want to see more about this. Also, the design water properties you might be using for a heating plant, or perhaps the cooling water properties you might be using for a cooling plant. You can go in there and modify those properties if those proper connectors are available in your project in the first place. But you know what? There's so many more schedules you can work with. If I go over to the schedules quantities list right here, let's just take an example out of the electrical handbook. If I go over here to my circuit overload check coordination schedule, anytime you see the coordination word there in front of a schedule, it's designed to help you manage some of the information and juggle all this data inside of Revit. You know, in Revit, whenever you create a circuit, it always defaults, no matter what the actual load on the circuit's going to be, it always defaults to a 20 amp rating. And while, okay, that's perhaps a reasonable default since the majority of a lot of our building circuits are 20 amp, that's okay, but there's a lot of other scenarios when that's just not acceptable. Like right down here, I've got this panel where I have a 26.4 amp load on it. Well, maybe I want to increase that. I want to make that 25 amps. Now I'd have to tab through into that circuit to find that information out. In this case, you can see as I go to 25 amp, I'm still exceeding or not quite meeting that 80% rate. In fact, I'm under the load still. I need to go to 30 amps perhaps. So if I go to 30 amp, I'm at 88% of the actual load on that circuit. So I'm still too small of a breaker in this case. So maybe I want to jump to a 35 amp or a 40 amp breaker. And when I do that, I can get the non-red line over here telling me, yep, you're good to go. Over here, similar deal. I have this 38 amp breaker or 38 amp rating on this particular circuit, or 38 amps of power being drawn. I want to make this like maybe a 45 amp circuit. Nope, still too close. So let's make this 50 amps. So I can go ahead and make those choices here to make sure that I'm within tolerance. Now that happens to be a main switchboard distribution section 1. A 50 amp breaker is probably irresponsible and not quite right, so I probably should increase that. But you know what? You have, well, maybe not, because that's actually distributing to circuits 1 through 8. Maybe that is correct. I don't know. Depends on you. You're the engineer. You can make those decisions, but you have the information presented here at your fingertips to give you that kind of data. Now our whole goal inside of Revit is to enable communication between different disciplines as well, and this is where the discipline coordination schedules can really come into play. So let's take a look at another area here. In fact, this isn't listed explicitly as a coordination schedule, but it does assist with a lot of the coordination. I have right here a motor list. It's got my load calculations built into it. Now the actual E_motor list would be the one that I'd probably throw in a sheet, wouldn't have all the colors and would have fewer fields. That actually shows the real data that I want to output in my construction document set. But this load calculations list right here, the purpose of this is to enable some communication between the different disciplines in a project. So all of the motors or all the components that show up in this list are all mechanical equipment that all have motors. You can see there are boilers, there's pumps, there's rooftop units, there's VAV boxes, and all of those have been checked to include in the motor list because they have motors. Now the electrical engineer can go through and decide when they have validated the actual properties on those explicit pieces of equipment. In this case, you can see they're all checked in green, and that means that they've already all been validated. But if I go over here to the right, you'll start seeing some properties like the FLA property. I see I have an FLA. Anything that's in orange is being calculated automatically. Now in one of our previous videos, we were talking about how to go through and override some of the values with our auto-sizing components. You can actually override those and have it do some of the additional calculations for you. In this case, I have access to those exact same properties. I can see what's calculated, and I can see the input property, and if it's appropriate, and I go, you know what, 2.1 amps is not what I want 2.5, and so I can enter that as the value. That'll become the new value that gets reported to the actual real schedule over here in the motor list. But I have control here to put in whatever overrides I feel are appropriate when I'm working with this. Now let's take another example out of the mechanical set of schedules. I'm going to scroll down here and take a look at one that's going to help me balance some of my airflow information in my individual spaces. As I scroll down, I have one near the bottom that is called my Space Design Airflow Summary. This particular schedule right here is built to assist me in seeing every single one of my spaces that exist in my project. So I can see right here I've got the Hall of Justice right here, or the Hall of Justice South, right? Any one of these. I can take a look at them and I can see exactly what the calculated supply airflow is supposed to be. I can see what the actual supply airflow is for my supply airflow diffusers, and this is based on what type of connector is on the actual diffuser itself. I can see also what my actual return airflow is, my actual exhaust airflow, and if I have a positive or negative pressure in the room. And these are also color-coded here, so I can see if I'm over or under my design calculated airflows by a certain percentage. In this case, if I'm outside the 5% range, it'll turn red, plus or minus. Over here, for my balancing, if I am outside of, I believe it's, well, if I'm exactly balanced at 0 CFM, meaning that I've got exactly the same supply as I have returned, it'll turn green. I'm good to go, equally balanced. Or if I wanted to say positive or negative pressures, I can see those values here as well. Again, just a design assist schedule there to help you with your discipline coordination. All right, here's another one that I have a lot of fondness for. Over here we've got an ASHRAE ventilation calculation. This is going to help me with calculating out my ASHRAE table 62.1 calcs. Down here, one of my zones that I've configured, in this case happens to be a VAV box supplied zone, but I can actually take all the VAV boxes or all the zones labeled after certain VAV boxes connected to a certain air handling unit and get their totals as well. In this case, what I'm going to do is take this one zone specifically and tell it what type of categories of occupancy I have in these individual spaces. I'll do this one here live in front of you. Now, two of these are going to be offices. So I'm going to scroll down and find my office spaces, and I think it's the two larger square footage spaces here are both offices. So I'm going to go ahead and grab those as office spaces, and the smaller square footage one is actually a small corridor between the two. So if I go down, scroll down, find corridors, let's see here, what do we got? There we go, is a corridor. I can see, it's got some properties about what the outdoor airflow rate per person in that unit needs to be. Well, then I can also come through and tell it how many people are going to be in these spaces. So maybe for these two office spaces, I've got 4 people each. And so I got 4 people here, 4 people on the lower one down here. You can see calculations happening in my schedule automatically about how much outdoor airflow each person's going to need. So then let's take this, this corridor and say I'm going to have maybe 3 people in that space at any given time. So I'm going to go ahead and calculate for that. So I got 4 CFM of air there. I can also determine then how effective my air distribution is in these spaces. And for my purposes here, I'm going to go ahead and put 80% efficient, or 0.8. So we'll just kind of put that all the way down. As I'm putting this tells me about how much air I'm going to need to acquire from outdoor, in this case 108 CFM of air, to distribute to this particular zone here. Now again, I could go through and tally up all the VAV zones that are attached to a certain air handling unit, and then take that information and figure out, how much outdoor air that air handling unit has to exchange to make sure that I'm getting some clean outdoor air, some fresh air being brought in. But this table here is designed to help you with that calculation and to give you all the information. And of course, since this isn't a schedule and those calculations are happening live, you can of course back check all of our math. Therefore, you can trust where these calculations are coming from, so you're not manually running these by hand externally from the Revit environment. It's all happening live right here. The greatness of this is that when the architect, not if, but when the architect decides to change their floor plan layouts and your space is updated accordingly, when this square footage changes, all you have to do is change the number of people that are going to potentially be in that space that's been calculated, and the rest of these calculations have already figured themselves out all the way down here at the required outdoor airflow per zone. Right? So, I've shown you a number of different design validation and discipline coordination schedules that you've got here. Hopefully, this gives you a lot of information about how the MEP Productivity Pack's discipline coordination schedules can help you in your design workflows. Want to see more about the MEP Productivity Pack? Click any of the links on this little slide here so that you can go through and view some of the other videos that you may not yet have seen. Thanks for watching this presentation. We look forward to seeing you in other CTC presentations in the future.